Algebra 2 Honors, Lesson 11.5, Infinite Geometric Series. So here's the argument. I'm standing out there 8 feet from a wall, and I go halfway close. So now I'm here. Then I go halfway again, halfway again, halfway again. Do I ever get there? This is a calculus concept. We call it a limit. And we write it in this way like this, saying as the situation goes to infinity, as we continue to get half and half and half closer, most people will say, yeah, eventually you'll get so close that you're basically touching the wall. The half will get so small that it'll be basically a trace amount. You won't even notice it. Some people don't buy it. It's a nice philosophical discussion. Won't go into it right now. So the fact of the matter is we can add up the entire geometric series, an infinite geometric series, but only if the R value is between -1 and 1. If it is, we have a series that converges. In other words, the values out towards infinity get so small they don't even impact things. Pi and E are calculated by an infinite diverging geometric, well, not geometric, but series. If not, R is absolute value of R is greater than 1. The series diverges. And I'll try and go into more detail on this as we get along. If you imagine a ball being dropped and it bounces, and each time it bounces a little bit less, a little bit less, a little bit less, that's a series of converging so that the height will eventually be 0. How far the ball traveled is another story, but let's derive. And oh boy, I haven't done this in a long time. What's the formula for the sum of a geometric series? I'll break it into pieces for this one. Sn, well, we'll start with the original. A1 times 1 minus r to the n over 1 minus r. Split it into 2 pieces. Sn equals, well, actually, we'll change it. No, we'll just keep it. A1 minus A1r to the n over 1 minus r. Sn equals A1 over 1 minus r minus A1 Rn over 1 minus r. So we've been practicing this for a little bit, and you'll notice that as n gets really, really big, some strange things happen. Let's imagine it's 1/2. 1/2, 1/120, 1/256, 1/6564, or whatever 2 gets up to. As this number gets bigger and bigger, this value gets closer and closer to 0, so that out at infinity we could say it's 0. So the entire second term, it's r to the n in it, goes to 0. And we are left with the sum of an infinite geometric series is just the original value A1 over 1 minus r. So the wall is 8 feet from the wall. Actually, no, we're not going to do the wall. You have to set that up a little bit differently. But let's try these. There's A1. R equals 3/8 divided by 1/2, 3/4. So the infinite series sum is I thought we'd write it with this, but we don't. We just write it as n. 1/2 over 1 minus 3/4 equals 2. Now, I actually don't mind checking this out with the calculator. A little bit tough with the size here. See if we can do this. Not quite. There we go. So that was 1/2 plus, I can't remember, 3/8 plus 9/32 plus 3 divided by 8 plus 9 divided by 32 plus, each one goes up by multiplying 3/4. 27 divided by, 4 times 32, that's tough. 128. Do one more. Plus, and I'll just write it out. 27 divided by 128 times 3 divided by 4, because that's what it's going to go up by. And we get 1.53. If we kept going, that number would keep getting closer and closer and closer, but never quite get to 2. It's like an asymptote from graphing. It's there, it just takes a long time to get there. So this one, A1 equals 1, R equals -2/1 equals -2. There's no infinite sum. The R value is greater than 1. The absolute value of the R value is greater than 1. So, a little sigma notation. Can you find the sum? Well, this is actually fairly easy. A1 equals 24 times, just 24. R equals -1/5. Sum equals, you know what? Just right there. 24 over 1 minus -1/5 equals 20. Sit down and start blasting those out, and you'll get to 20. Helps if you can read sigma notation. So write a repeating decimal. Whoa. Where do we get repeating decimals from? Repeating decimals are just geometric series. They've been added up. There's 2 ways to do it. We can write that as 39 over 100. Well, yeah, we'll just do that. Over 100 plus 39 over 10,000 plus 39 over 1,000,000. Keep going. A1 equals 39 over 100. R equals 39 over 10,000 over 39 over 100. In this case, 1/100th. Has to be. I was thinking it was 100 for a second, but then you can't add them up. It's not an infinite series. So the sum in a fraction form will be 39 over 100, 1 minus 1/100th. 39 divided by 100 divided by 99 100ths. And that's what we get. 13. Now let's do this right. The hundreds cancel. 39 over 99. 13 over 33. Put in your calculator to check. Another way to do it. This has been a common way I've seen. The repeat happens after 2 decimals. So we take this 0.39 repeating, and we multiply both sides by 100. We get 100s equals 39.39 repeating. Now I'm going to erase this just because I need to see it. And then actually, no, I'll leave it. Take the original equation right underneath. Subtract 99s is 39. S equals 39 over 99 equals 13/33. So my apologies. I went through that relatively quickly. It's a lot to cover, even though it seems like a very short subject. It's a lot to do. You're going to have to play with it and see where it takes you. Good luck and happy mathing.